Okay, so now we're going to do concept 2, number 4. Okay. So an airplane's traveling at a speed of 85 meters per second. So let's just pretend this is our airplane. Okay. At a height of 400 meters. This is 400 meters. And it's traveling at a speed of 85 meters per second. Okay. So it drops a bowling ball. How far horizontally will the point of the release will the ball hit the ground? Okay. So we'll start with that. So we can use the same thing that we did in number 3. So the change in x equals 1/2 at squared plus vit. Okay. There we go. Okay. So the change in x, we're just going to work with the vertical velocities again. So the change in x, the vertical component. So the change in x is 400 meters equals 1/2 times 10 meters per second squared, because that's the downward acceleration due to gravity, times the time squared plus initial velocity, which is 0, meters per second squared, times time. So that goes away. And so 400 meters equals 5 meters per second squared times time squared. Okay. So time squared equals 80 seconds squared. So time equals about 8.944 seconds. Okay. So we'll just bring that over here. We'll use that over here. So we're going to use the same formula, but we're just going to do this for the horizontal components. Okay, so change in x equals 1/2 at squared plus vit. So the change in x is what we're looking for, the displacement, equals 1/2, and then there's no acceleration because it is not vertical, so 0 meters per second squared, times 8.944 seconds. That all goes away, plus the initial velocity from the formula, from the problem, is 85 meters per second times 8.944 seconds. Okay, there you go. Okay, so if that's solved out, change in x equals 760.263 meters. Okay, so that's the answer to the horizontal displacement. And so then it says, neglecting the air resistance, what will the vertical and horizontal velocities of the bowling ball be upon impact? So to do that, we're just going to find the final velocity. So here, let me just section this off. So the velocity final equals the acceleration times the time plus the initial velocity. Okay, so we're going to use find this for the vertical originally, okay? So the vertical velocity, so v sub fy, okay, so the acceleration is 10 meters per second squared because it is there's gravity working on it, times the time, which is 8.944 seconds. So those cancel out, the 2 cancels out. And then plus the initial velocity is 0 meters per second. So that cancels out. Okay? So the final velocity, if you put it in your calculator, comes out to be 89.44 meters per second. Okay. And then, so if you use the same formula from here, and you do it for the x component equals, there's no acceleration because it's the horizontal components, so it's 0 meters per second squared times 8.944 seconds. Okay, so that's all to 0, plus the horizontal velocity originally, which is 85 meters per second. Okay, so the vertical velocity, the horizontal velocity, my bad, is equal to 85 meters per second. There you go. I'll give you the whole paper. Okay.